Hello, friends, and my dear students. Welcome to session 6 on projection of solids demo. We have started with projection of pentagonal pyramid demo. We have completed 2 sessions. This is the third session on pentagonal pyramid. Overall, this is the sixth session covering square pyramid and pentagonal pyramid. And this, as you already know, we are doing this how to do a problem in pentagonal pyramid using solid edge we are doing. Okay, that means it's a pure demonstration using solid edge, and by this you know finer aspects of it. So many new commands you learn and finer things what you have to do and how to identify intersection point, how to zoom and all that. So many things you are learning. Please learn. And before going to these things, you please go through my sessions under projection of solids. There are so many such sessions on projection of solids where you learn completely this subject. That is projection of pyramids, projection of prisms, and also projection of cones also. Everything you will know, perfectly will know if you go through my sessions. This is a demo. I have taken up the one of those problems what we have done in the class, that is in the sessions, that is problem 8 under pentagonal pyramid, that I am showing you the demo. Okay, how to do it. See here, we have come to this stage. See here, this is where we were. That means it is corner on HP such that the axis is inclined at 40 degrees to HP. In this position, when you look from the top, how it appears, I have written. Okay, now the problem is keeping axis inclined at 40 degrees to HP. This solid has to be rotated to VP in such a way that this axis, this is axis, no, this is not the extrude length of the axis, top of the axis, such that the top of the axis is inclined at 45 degrees to VP. Okay. Now in the entire process, the inclination to HP, that is 40 degree, I'll make it constant. That is why this top view won't change. That is why, okay. Anyway, first thing I'll tell you, I'll go for the move command. Move. Okay, this copy, let it be there. Copy is there. Okay, I'll select this and I'll move it with reference to one point. Okay. Then put escape. Okay, now as you know here, this I have moved it here. Now as you know, this top view and this top view remain same way because the inclination to HP is same. Now in this position, since inclination to HP remains same, even if you rotate O, okay, keeping D fixed, even if you rotate O this way, so that base comes nearer, or O, if you rotate O this way, such that apex comes nearer, whatever you do, the top view remains same. That is, the second stage top view will be same as third stage top view. But in this problem, they are clearly given base should be nearer. That is why I have to rotate O1, that is O this way, so that base comes nearer to the observer. Okay, now what I'll do, I'll take rotate command, select the entire thing. Okay, let us say this is the O1 point now. Let it be fixed point. This O is the moving point. If I move this way, apex is coming nearer to the observer. But if I move it this way, base is coming nearer to the observer. You do it in such a way that the angle is 45 degrees. Okay, now is the top view of the axis is inclined at 45 degrees to VP. Anyway, you just test whether you've done it correctly or not. Okay, this. This top view of the axis is inclined at 45 degrees to VP. It is perfectly okay. Okay. Now, as you know here, these things I'll tell you. Now, if I say, now the top view of the axis is inclined at 45 degrees to VP. That's why I made O1 inclined at 45 degrees to VP. Please understand, in this position, change of position, I've taken 3 steps. First step, second step, third, that is first stage, second stage, third stage. In third stage, as soon as you look at this, you should know I have brought this pentagonal pyramid to a complex position. That is, axis of this is inclined at 40 degrees to HP. That I have not changed. Axis inclined at 40 degrees HP will remain same. But the change between this top view and this top view is keeping axis inclined at 40 degrees to HP, the top view of the axis is inclined at 45 degrees to VP. That means I have given inclination to both HP and VP. In this complex position, when you look from the front, how it is seen in the front view has to be drawn. That is important to us. Okay. In that way, the final front view, when the axis is inclined at 40 degrees, top view of the axis is inclined at 45 degrees, how it appears in the front view has to be drawn. In this complex position, here to draw the final front view. Okay. Now you see here, first we'll take the projectors. On this, actually, you should find the axis. Okay. And see here, even here also, take care of the end point. Okay, end point. From here you take. Okay. From E also, C also you take the point. Okay, C and E should be here only. No, actually you can stop here on there. C, B, you take B from here. B, if you take here B, you see here, B is on this line. Okay, B, you take it up to that. Then A also, you take it. A and B should be on this line. You stop at this. Okay, then E should be on this line. You stop at this. Okay, in that way you have got the points and all that. I have got all the points here. Okay, see here, the first before getting confused, we'll first have the points here. Okay, these points you take and make it 2, it will be better. See here, O from here, O here, O dash. Okay, then you see here, this is AB. A will be here, correct now? A is here, B is here, okay, C is here, E is here, okay, but D line I have not written anyway, that will do. Okay, this D line I'll do this from here now, from the end of this I'll take, it is resting on corner D only. Oh, okay, this is point D. Okay, this I'll take 0.2 thickness and I'll name this corner also. Okay, now as you know here, immediately before we forget, we always have this point there. This is O dash is there, A dash, B dash, C dash, D dash, E dash, and all that you have. Okay, O1 dash also we will have it ready. I'll tell you when you have to insert it properly. Okay, now you see here, this point, as you know, is O dash, correct now? This is O dash, and this on this A and B you should get. Okay, this is A dash point and this is B dash point. Okay, and then this is C dash point, this is D dash point, and this is E dash point. Okay, now you have all the points ready. Check here, this on this A and B, A here, then B here, on this E and C, this is C, this is E, on this D. Okay, now I have told you I am looking from here, this O1 dash we'll have it later on. Okay, now when we are looking from here, okay, first step I've told you, base is nearer anyway, we'll do it as a second step. First outer boundary will complete. Outer boundary, okay, outer boundary will complete, directly darken it. Okay, You can enlarge, zoom it also, because there won't be any confusions. From this A, E, B, C, and O. Okay. Now you see here. This is the outer boundary. This is the first step. Okay. This is the first step, outer boundary. Since base is nearer than the apex. Okay. Base can be seen because when you're looking from here, apex is here, base is nearer to the observer, complete base can be seen. Again, you see here, this is the practically how to do it in the exam, I'm telling you. Okay, you enlarge it again. If you want, you can still more enlarge it. Okay, once everything is done, then base is nearer, no? Okay, then you see here 0.5, you darken the base. Okay, but darken the base. Now you count the number of edges. 5 plus 2, 7 edges over. Another 3 more edges to be done. One is O dash B dash, slant edge, O dash E dash, O dash D dash. O dash B dash, if you see here, it is the nearest corner edge which can be seen. That's why O dash B dash can be darkened. Then O dash E dash and O dash D dash, if you see their faraway edges, cannot be seen. Hence it will be dark dotted. That is why what I'll do, from O dash B dash, I'll darken it. Okay, this will be darkened. Then O dash E dash and O dash D dash, they are faraway edges. As a result, this OE see here, okay, you see here, this O dash E dash and also O dash D dash. E and D are the back corners. Okay, E and D are the back corners, cannot be seen by the observer. As a result, the line type you make it dark dotted. In that way, you are able to complete the problem in all respect. Your O dash B dash, you have darkened it. Okay, O dash B dash, you have darkened it. Okay, O dash E dash and O dash D dash, since D is here. Okay, if it is gone somewhere, anyway, I'm doing it again. Okay, D is here. Okay, D is here. E and D are the back corners. For an observer who is looking from here, cannot see the back corners and back edges. As a result, O dash E dash and O dash D dash have made it dark dotted. In that way, I've got an account for all the 10 edges. Now, what you do finally, without forgetting, okay, show the axis also. Axis point is here. See here, that's what I've told you. These are all the finer things. Okay, you do this. Once you do this, axis is this. Now you immediately push the axis to this point and show the axis representation. In that way, you are not doing any mistake here. It is 100% perfect. I've shown here O dash 1 dash is a axis which I have shown it as axis representation. Now this problem has been completed in all respect, and there is absolutely no mistake. The problem is, as you see here, the axis is inclined at 40 degrees. Keeping 40-degree constant, rotated in such a way that axis is inclined at the top view of the axis, or top view of the axis is inclined at 45 degrees to VP. In this complex position, how it is seen in the top view, that is this. How it is seen in the front view is this. This I have taken care. Okay, you should know what are the visible edges, what are invisible edges. Take care of all these edges. And finally, I'm telling you, O dash 1 dash is an axis representation that has to be shown properly. Then only it will be 100% perfect. Okay, this I have told you. This is the end of session 6, and this completes problem on pentagonal pyramid. We'll continue in the next session. Thank you very much for watching, friends. Thank you very much. Thank you.